Hello and welcome to WorldCanvass from International Programs at the University of Iowa. I'm Joan Kerr. We're in the Senate chamber of the Old Capitol Museum on the Central Campus, and glad to have so many of you with us this afternoon. This is the fourth program in a four-part series on the language of the brain. We've been covering a lot of territory in the earlier parts of this series, and in this final program, we're going to take a look at a slightly different approach, talk about the field of artificial intelligence. Our very special guest is Kareem Abdel-Malek, Director of the University of Iowa Center for Computer-Aided Design. And I'm so happy to have you here, Kareem.
Thank you very much.
Oh, no, it's a real pleasure, and there's so much to talk about here, and all of it is really quite foreign to me. So I'm going to ask you very basic questions. You can help me understand what artificial intelligence actually is.
Sure. So it's defined as any software or machine that exhibits intelligence. So it's software or machine that exhibits intelligence. Give an idea or a couple examples. You go to a bank and you want to withdraw some money, you put your card in, that machine in the back that decides of what to give you, why, and checks your security and so on, has some sort of program inside. Another example is that camera that she's using right now. It used to be that you would have to adjust the focus, you would have to adjust the aperture and so on, so many parameters. Well, today there's a little program in there that does all that for you. This is at the very, very basic level. At the higher level would be a robotic person that walks inside the room and says hello and how are you and can talk with you. That would be the other side of intelligence. A software, so that would be hardware. A software would be, you know, chess is well known as a intellectual game. And you know, a few years ago that IBM built this incredible computer software that has actually beaten the best chess player in the world, a Russian person. So it's all of this.
And so when was the earliest development of what we think of as artificial intelligence?
People say about 80 years ago or so.
Yeah, wow.
So,
wow.
Yeah.
And so you're in charge of the Center for Computer-Aided Design, and you're teaching students every year. Let's get a brief look at what you do here. What are some of the things we're doing at Iowa?
We have 7 units within the Center for Computer-Aided Design. It's called CCAD for short, and one of those units is at the airport here in Iowa City. We have jets, we have 2 jets, we have a helicopter, and we study the cognitive war fighter load. So as a pilot, a war fighter is engaged in a battle, and they have communications with the command, they have avionics, they have all sorts of information coming to them. They have to make decisions very, very quickly, split of a second. So what we do is come up with programs, intelligence that would enable them to make decisions much, much faster. Another program is called the Virtual Soldier Research, and that's all about creating a virtual person inside a computer that's able to think, test things for you inside the virtual world. So you're creating a tank, you're creating a weapon, you're creating whatever it is. It's all inside a computer. You want to send that virtual person to test these things for you. A third program would be robotic things. For example, we've been successful at creating limbs. As you know, because of the wars of Afghanistan and Iraq, there's been a lot of amputees. And nowadays, the technology allows you to replace a missing limb with a prosthetic one. It's mechanical, however, it's controlled by the brain. So we interrupt the brain waves, it goes through the arm, we check for the neurons, signals, and then we provide that power to the robotic arm. Let me mention one more, which is still under the center, and this is all about you've heard about 3D printing, where you can create a plastic part, or basically it's a machine that brings some material and you layer the material, you create a part. That technology is very, very well established. What we're trying to do here, and so is many other centers around the U.S., I'd say about 6 or 7, but what we've been very successful here at Iowa is to recreate skin. So using that 3D printing, we get stem cells, we work with the doctors to get that. So it's our engineers, the doctors all together, and you're able to print for people who have lost a lot of skin because of burn or anything else, you're able to recreate this. It's not artificial intelligence yet, but what if soon we're able to recreate an organ? And then after that, you know, I'm hoping I get another brain at some point. So I ordered one already.
How is it possible, though, to use a 3D printer to create new skin? I don't understand. Who would even think of such a thing?
There's a lot of effort at stem cell, and that's an area, it's not my area at all. But I know they are able to harvest those. They're, you know, it's just very similar to harvesting skin graft and put it somewhere else. I think that technology is coming about incredibly fast. If you talk about AI in general, I can tell you, I've told you where we are today.
Sure.
And let me tell you what, and maybe some of you have heard this already. So you know Google, a very large company, very successful. They, today you sit at a computer and you're able to type something and you Google that thing. So the chief engineer at Google, and many of us believe this, and so I'm going to tell you that because I think it's very powerful. The chief engineer at Google said that in 5 years, you will be able to do this. You just think, and you Google. So I just Googled Joan Kai. And so no connection to computers. It's just immediate connection between you to a computer. This is 5 years from today. What they also said is that in 2045, and this, if you haven't heard this before, it may be a shocker for you, but what they said is that 2045, in the year 2045, we shall become immortal. That means your brain will continue to grow and flourish in a different life. And so let me explain that a little bit. You know, everybody has a phone. And so here's my phone. I don't remember my wife's, she's here by the way, so I don't remember her number. So I put it inside the machine. Somebody else gives me a phone number, I put it in here. Slowly, I'm loading this machine. I don't remember these numbers anymore, but it does. So imagine if you had 1 million of those, just 1 million, access to a supercomputer that has 1 million CPU like this. And the memory that's inside, the hard disk, 50 million times that hard disk. That's all coming. Imagine now that you've loaded this with so much information, including you. That means it knows your character. It knows what you like, what you don't like. You've basically unloaded your brain into a computer. Google believes they can do this. In fact, I'll go a little extra. There are 3 centers around the US where you can present yourself and they will take 3D pictures of you. So you stand there, the camera goes around, takes 3D pictures of you. All of a sudden you show up on the computer, but you're just a body. It's your body on the computer, every little detail of you. Then you go another place and you speak. You start talking so it recognizes your voice. Then the computer starts asking you questions. What's your favorite color? Where were you born? How old are you? Thousands of questions. All of a sudden the computer understands. The computer starts thinking. It kind of adapts your brain. And so that's the artificial intelligence that's coming. And what Google is promising is that by 2045, your entire brain is going to be uploaded somewhere. And it will continue to live. And it says, this is Google, it's not me. I believe in it, but that's who's saying it. They're saying that our bodies are just transient. So your character, your brain, your psychology, all of you is now on the computer and will continue to live.
Until that computer crashes, and then it's all done.
So it brings a lot of issues, ethics, security, you name it.
Yeah, so what are the ethical issues that, with the things that you're currently working on? I'm sure that all the time you're thinking about something that could go, if a certain ability were in the hands of the wrong people, as we classify the wrong people, they could do something that would harm populations. I mean, what kinds of ethical problems have arisen in your own thinking about the work you're doing?
It's a very good question. And everybody's different.
Sure.
My thinking is that science is very important, and that you have to pursue to the maximum there is. So let's talk about that example with uploading your brain to a computer, and with the thought that the risk that somebody's going to hack into it or will send you a bug to a computer and mess it up. To me, it's very similar to saying, let's not build a plane because it may fall someday. Well, that's true, but we have to build around it. And so from my perspective, it's just me. Everybody has their own. There's certainly two different views on this. In my mind, we just charge forward and we pursue what we think will help people. So that extreme, which is 2045, is one extreme. To get there, I think there's tremendous help that computers can provide to medicine, to health. I mean, I think of artificial hearts that now have software that recognize your physiology. They activate your heart just for you. We were involved in a project with a big company in Minnesota called Medtronic, a very large company that does medical devices. And that particular device we worked with is something you plant underneath your skin in the waist area, and the leads go up all the way to the cervical spine, all the way up here, and it pumps some electricity into your spine, inside your spine. And what that has done is solved 62% of chronic back pain. So little softer, little device, but look what the effect has been. And so I just think that whole technology is coming about in force, and it's just here.
Yeah.
It's here, and we have to deal with it.
And some might fear or have feared in the past that computers could become so powerful they'd take over the world, really. And we all know 2001: A Space Odyssey, and how refuses to do what Dave wants him to do, and that's how many years ago now? 50 years ago, maybe, for that film. So. Is this ability of these supercomputing machines to think like individuals, is it something we need to be worried about?
I think so. I can point to several projects that computers have taken over. Are we scared that the computers will start communicating with each other and take over the world and be a force of bad and so on? I would say yes or no. My personal view is no. I just don't think that's going to happen. You worry about bugs and viruses and terrorist activities and so on, but I just doubt that to some point that the brain of the computer is going to be better than what we can do to the computer. I just don't think that's going to happen.
And is there, right now, is it still necessary at some level, for an individual human being to be involved in setting computers on their way? I mean, do we need to have, is there human intervention that we might not see, but that's always going on? Maybe not in the ATM machine. I mean, that's reading your card and doing whatever, and there's no individual watching it, but could you imagine a time when humans won't be actively managing these machines?
I can tell you, I visited a company in Japan that has, my background is robotics, so I worked a lot in that area. I visited a company in Japan that had, they make something, it's a manufacturing environment, and they had robots in the entire factory. So they had one room that had about 5 people, big factory. All robots, all robotic arms. It's not robots that walk, it's just robotic arms that take things, make things, weld things, and so on. Here's what was amazing. When one of them went down, another robot went to fix it. and it was just, wow. It was cool to see, and this was a few years back.
Wow. Well, so help us understand what virtual reality is.
Virtual reality is a field that allows us as humans to live in a different world that may or may not exist. And so, to give you a simple example, we work with the military quite a bit, and they make a tank. They make tank designs. Every few years, they make a new tank design. Car companies, they make a new car, and an assembly line for that car every year. The design of that car is all happening inside the virtual world. right? We don't do tests anymore as engineering folks. You want to do a stress test, you actually design it on a computer, you model it on a computer, and then you affect stress on it, and you see what happens, all inside the computer, before it's made. Before it's made. So to give you an idea, the tank that I was talking about takes about 10 to 15 years to make. That's the first tank. We're not ordering 500, we're just ordering one. So the first, what we call a prototype, 15 years. And it takes $2 to $3 billion, will be. $2 to $3 billion, 10 to 15 years. And most of the work and the cost is that we have to make the tank, send it on the hill, test it, drive it fast, and so on. Except for all the engineering. Now, the thermal stuff, the what we call aerodynamics, the stress tests, all that inside a computer. We want to send a virtual person, instead of actually making it, so we want to reduce that time. We want to send a virtual person inside to test these for you. That's what we call virtual reality. We create this human, and the tank is inside a computer. You send the human, in our case it's called Santos. You're all welcome to come and visit, by the way. Santos goes out, we say, hey Santos, drive this car or this tank at 40 miles an hour. How do you feel? Can you reach this? And Santos, the virtual person, starts reaching. He tells you, I don't feel very good. Okay, Santos, carry this box. Today, you are an 18-year-old kid, a Marine, and your weight is this much, your height is this much. This box is 80 pounds. Go ahead and try to do it. And Santos goes and tries to carry the box. Sorry, I can't do this. My stress on L4 in the spine is higher than I can do. Don't ask me to do that. And so that's one aspect of virtual reality. The other one that we're very involved in, we have a facility here at Iowa, and again, public is invited to come and visit. You wear 3D glasses. So this is the opposite. This is, instead of us sending a virtual person into the computer, this is us becoming in the virtual world. So you stand in front of a big screen, and the big screen has things that float because you're wearing 3D glasses. If you've seen the Avatar 3D movie, very, very similar, except that it's interactive. So you walk into the screen and things start floating at you. And so let's say a car shows up. It's in middle space. You're wearing 3D gloves. You grab the car and you open the door. Now you walk into the car. It doesn't exist. It's virtual. That's what virtual reality is.
Wow. Wow, how do you teach this to your students? It's an amazing thing, isn't it? And I imagine the students who come into this field may have already, they might be experts at playing video games and so on, doing a lot of things that involve sort of pretend universes out there. Does that help them come into this field, do you think? Is it a useful skill?
Somewhat, yes.
Yeah.
It helps with the eye motion coordination.
Yeah.
The kids today understand the 3D depth much more, what we call spatial relationship, where are things in respect to other things in 3D. Very powerful. Mm-hmm. Some of them have already in school got into the programming aspect. Yeah. Whether it's artificial intelligence or virtual reality or any of the programming aspects, they get into this very, very early. What's missing, which I think needs to be addressed, maybe another show, is the level of math preparation. All of this, everything I'm talking about, everything really comes down, at the end of the day, it's math, physics, the basic sciences that are I think the preparations are not just quite there.
Right. Huh. So, within the larger world, just moving on beyond the University of Iowa and what we're doing here, what do you think, this Google stuff was incredible, but what are some of the other things we should be expecting to see, or some of the things that excite you most about what we're learning?
I think, the field of robotics, artificial intelligence, virtual reality also, has been more promises than delivery for many, many years. And the reason is you go to a movie and it portrays so much more than what we have. A reminder of this is how they sent the first person to the moon in stories before we actually went there. Very similar now, but I do believe that at this point, all of these very intelligent things are coming about very strongly. You can go to even a Target, and you'll find I think it's called a Roomba, which is a robotic device, very inexpensive, that cleans your carpet. It just does it all day long and doesn't get tired. It's a few $100. You program it and you say, I want, these 4 or 5, it's very efficient. It doesn't complain. It doesn't, you don't have to feed it anything. And this is a sample. I remember another example I went to, this is 7 years ago, so I don't know where they are now. I haven't followed that. But I went to a hospital that had robotics in it, intelligent robots. And to go from one room to another to offer the medication is the function of one of those robots. It's like a cabinet that had wheels, that had little eyes, cameras. It understands where the walls are. So of course, I'm going to try it out. So I went and stood in front of it as it was walking. It stopped, excuse me, and it went around me. And it went to a room, and to deliver the medication, it had many drawers, and it understands that room is this patient. It checks, it reads, it opens the door, and it serves the medication. Amazing. This was 7 years ago. I can't imagine what's coming now.
Yeah.
I'm involved heavily. That's another one that people may be interested in. Very heavily with the military design of new stuff. There are multiple efforts. The one that we just came back from last week is in Tampa. It's the United States Special Operations Command, U.S. SOCOM. And there, the admiral, I think is a one-star admiral, wants to design a suit for the special ops. Those guys are just amazing. They're the ones that got Bin Laden. They're just very special, special projects, very highly trained. So what they have now a mandate for is to build a suit that is incredibly strong. Just incredibly strong. The mandate for that is that the person walks into the room, and even if they're sprayed with small arms, AK-47, nothing happens to them. Just this. Second, which is amazing, to be able to run at 22 miles an hour. That's a little faster than Usain Bolt. That's an incredibly fast suit. So to do this, they're designing these exoskeletons, which are mounted. Exoskeleton is a robotic device that kind of embraces the body. And so you're trying to lift something, the device knows, hey, lift, so it makes your arm stronger, and you're able to lift 400 pounds instead of 100. The third thing that they want the suit, it's called Talos, if you want to Google it. They have something about it, TALOS, Talos, Tactical Armed Light Vest, something. So Talos, the third one is that they're able to walk with it underwater about 2 feet below, so the body would be 6 feet under. All of this with all this equipment, gear, armor, speed, motors to power you, just an incredible task.
Wow.
Just amazing stuff, I think.
Yeah. Will the UI be involved in that research?
We have been involved initially. We're hoping to be much more involved. It remains to be seen, but they called us, which is a good thing.
Yeah, absolutely. No, that's great. Well, and also it's easy to see the immediate benefits of some of the robotic limbs and so on that you mentioned. What a gift to people, or someone with intense back pain, and now they don't have it anymore. It's incredible. Yeah, you're doing fascinating work, Kareem. I'm so glad you would come and talk with us about it. And I think we need sort of regular updates on this, because what you told us today is already pretty stunning. So I've been listening to Kareem Abdel-Malek, who's the head of the Computer-Aided Design Center here at the University of Iowa, engineering professor, and so on. And this is the fourth part of a 4-part series on the language of the brain. I hope you've enjoyed each part of this program. You can find all of it on UI TV, on iTunes, on YouTube, and also at the International Program's website, which is international.uiowa.edu. I'm Joan Kerr. Thanks for being with us, and please join us for the next WorldCanvass. Good night.
Thank you so much.